Hello, welcome to this discussion. In this section, we are discussing set associative memory through an example. Okay, consider a main memory of size 16 blocks, and each block size is 2 byte. Main memory is addressed by 5 bits. An array A16 of bytes is stored in the main memory from block number 0, byte number 0. There is also a cache memory having 8 blocks with block size of 2 bytes and is two-way set associative. A program accesses the entire array twice. Which element will conflict with A0? So let's address the first part here in this case, that which element is going to conflict with A0. So let's visualize this whole thing, and there is a start with this main memory which is consist of 16 blocks. Okay, so let's have a main memory which is consist of number of blocks, not very straight line, not a straight line. Okay, now but fine. So we have a block number 0, block number 1, 2, 3, and in that we are having a total number of blocks as 16. So indexing generally start from 0, so we have a 0, 1, 2, 3, and with this pattern last index is 50. This also have a main memory which is divides into a block. Each block contain 2 byte information, and let's suppose this is your byte number 0 and this is your byte number 1. So this is my main memory which is addressed by 5 bits and 16 blocks. Each block contain 2 byte. Also we have a cache of size 8 blocks. So let's have a cache of size 8 blocks in this case, and better line than the previous one, and now in this case it is having total number of blocks as 8. So we have this 0, 1, 2, 3, 4, 5, 6. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. I need one more, so let's have this 8 blocks. So 0, 1, 2, 3, 4, 5, 6, 7. I don't need this one. Okay, so it's there's one extra block. Okay, so one extra space over there. Anyway, so 0 to 7 indexing, and this is my main memory and this is my cache memory. This is my cache memory. Okay, so this is my, and this one is my main memory. Okay, so with the given specification 8 block, and again each is occupying 2 byte here in this case also. So we have a space for byte number 0 and we have a space for byte number 1. Now an array of A16, so there are 16 elements in the array. Few more calculation we can do over here. A16 of byte each element, so total amount of the main memory required in terms of byte is 16 bytes. Okay, and since my one block can contain 2 byte, number of main memory blocks required is 8. So I need 8 main memory blocks. Okay, so in this case so first it will access the array, the entire access twice. The memory is addressed by 5 bits. Okay, and if you look at the set associative, the standard division of the set associative memory is it is the main memory, the physical address divided into 3 different parts. There is a set associative division, and the first part is the tag field, the second part is your set index, and the third part is your byte offset. Okay, and we know that this in the quotient, this entire length is given as your 5 bits. So this complete thing is of 5 bits. Now we can further divide this thing into different parts, and we can not divide, sorry. Uh, okay, if you divide this 5-bit into this different fields here, then the tag, okay, we started byte offset. So since there are 2 byte, 1 bit will be assigned for this set. So 8 blocks, and it's a two-way set associative. If you divide this thing into 2 block size, the number of sets in this case will be equal to, this is set number 0, this is set number 1, this is set number 2, and this is set number 3. Number of set will be equal to 4, and number of sets are equal to 4. Number of bits will be assigned for this will be equal to 2. So 2 and 1, and remaining will form the tag field, that is 2. So this is your 5-bit division. Now if you go a bit more in detail, like 0000, this is my 5-bit address, and this is also address where your A0 will be stored. Further, 00001 is address of A1. Let me write 2 more address, 00010, 00011. So these are the address of your A2, and these are the address of A3. Now what will happen in this case is, when the first address will be issued by this processor of A0, because it is accessing the entire array twice, what will happen in this case is A0. So A0 is this, and if you divide this thing in different parts as per the division, this and this. So this belongs to set 0, and this says that byte number 0. So A0 will mapped here. It's a miss, but when the block will bring from the main memory, A0 will be mapped to set 0. In set 0 we have a 2 block number 0, block number 1. First one is empty, it will be occupied. But this A0 will not come alone. He will also bring A1. Okay, so, and that is basically is the standard term that we use here is known as your spatial locality of reference. Spatial locality of reference. So A0 will be a miss, but A1 will be a hit. Now you concentrate on the next address, A2. Again you further divide this thing into tag, set and byte offset, and if you do this thing you will find that this is byte number 0, but now this says that this is index is 1. So now this address will go to set number 1. Okay, so again we have a 2A2, and with that A3 will come. So now you understand the order, that first the 0th block of each set, or the first block of each set will be filled, 0, 1, 2, 3. So A0, A1 here, A2, A3 will be in the next set, A4, A5 will be in the next set, A6, A7 will be on the next set. So now we have filled all the first block of the each set. Then your A8 and A9 will be again going to fill up the second block of this cache. A9, A8, 8, 9, 10 and A11, 12 and 13, and finally A14, 1, 4 and A15. So this is how this will be set associative mapping, fill the elements, all the first block of each set in one iteration, come back and now fill the second block of each element in the second iteration. Now it is full, and now we need a replacement policy. So if you look at this arrangement and conflicting situation, if you say that conflict, okay, So no conflict occurs in this case. All are misses, but all the misses for the post reference. So which element will conflict with A0? His answer is there is no conflict in this case, and one of the reason you can say that because my cache size and the array size is same. So the first answer is no conflict. The second part of the question is find the number of misses experienced by the program is. Okay, so this question is about accessing the entire array twice, but I don't think that it will have any impact on this. In the first time access, all the misses in this case, when we are accessing for the first time, all the misses that occurred here is for the first element. So A0, as we can see, A0 is a miss, but A1 is a hit. So we can see here in this case that A0 is causing a miss, but A1 is a hit. Same situation is for 2 and 3, that 2 is a miss, then 3 is a hit, 4 is a miss, then 5 is a hit. So every alternative element is getting a miss. So the number of references, that is total number of references in this case, is total number of references are 16, and for alternative element we are getting a miss. That means A0 is a miss, then A1 is a hit. So we can say that out of 16, 8 will be a hit and 8 will be miss. This we are talking strictly about the first round. Okay, this is we are talking about the first round or the first iteration. So the hit ratio in this case will be, for first round it will be 8 hit and 16 misses, and that is equal to 50%. Now, but we have to answer for twice. Second round when you come, there are total number of reference second round. Okay, let me write this thing also. Second round total number of reference is again 16, but in this case my cache is full because of the first time access, and all the 16 reference will be a hit. Okay, so 16 references and hit in this case will be total 16. So total out of 32 references, 16 and 16, my total number of hits are equal to 24. So 32 reference in total and 24 hit. So hit ratio is 24 divided by 32 into 100 in terms of percentage, which will be equal to, which is equal to your 75%. So this will give you a hit ratio of 75%. Thank you.